live.
We're live,
Cutting to a minimum.
streaming out across the world.
Do I have control over your presentation? Do I have control over this?
You can ask me questions if you want via the chat window. I will be ignoring them until the end.
So do you want to leave it?
Yeah.
Oh, okay.
Cool. Thought I'd try and record it as well.
Bad idea.
Okay, let's get started. So, welcome to this presentation. 5 tips to modularize, reuse, and organize your development chaos. Quick disclaimer, this is actually not my presentation. This is my business partner Fabiola's presentation that she gave at the CLA Summit in Austin. I have been through it. I've changed all of the Z's to S's in modularize, componentize, and all of those words. If you spot any that I've missed, give me a shout. So, my name's Chris Roebuck. I'm a software architect at Delacor. Who's Delacor? We are a massive multinational organisation with 2 offices, one in Austin with Fabiola and Lewis, and one on the south coast in Portsmouth with me. What do we do? Software architectural design. We do a lot of what we're going to talk about today, so software best practices, training, implementation, helping customers who've got existing LabVIEW teams but maybe are struggling with reuse or style guides, things like that, help teams of existing LabVIEW developers. We do some custom training as well, things that maybe NI don't provide, things like VI Package Manager or deploying test stand. We do a little bit of training on that, and also some coaching for people that are looking to do CLD, CLA. We've now got a hardware engineer on staff, Lewis, so we do some custom hardware design, and we also do test data management. Software and deployment, because we found that actually deploying test stand in particular is pretty tricky. People wanted to know about it. Quick history of me. I started at Sheffield University, Sheffield Hallam, doing LabVIEW back in 1994. I did a physics degree, and then from there moved across to Jaysborough Laboratory, where somebody gave me a box instrument and said, "Here, make this do something. We've paid a lot of money for it." And then they gave me a copy of LabVIEW as well. So I played around with that for a year, which was good. Worked up in County Durham on some RF test projects for 8 years. And then in 2008 moved down to the south coast and joined Astrium, where I was for 4 years building satellite test systems using LabVIEW. Today we're going to be talking about reusable code. So before we get too far into this, I just wanted to go over some of the syntax that we're going to be using during the presentation. So when I'm talking about reusable code, I'm talking about groups of VIs, classes, libraries, might be tools as well, quick drop shortcuts, project templates that you're going to use in multiple projects. Things that you're going to find yourself using from one project to another. Anytime you find yourself creating multiple instances of something or copying something, anytime you find yourself doing Control-C on a LabVIEW block diagram and pasting it somewhere else, you need to stop yourself. That needs to be a sub-VI and it needs to go into a reuse library. So Control-C is out. Why should we do it? Because code duplication is the devil. It will reduce your effort. Ultimately, code reuse in the long term will reduce your effort. Both in terms of development, you're not pressing Control-C. How many times have we thought, how did I write this VI the last time I wrote it? If you've ever thought that, it's a reuse VI that you need. So it will reduce your development effort, and it will massively reduce your validation effort. If you've got a code module or a piece of a library that's being validated, if you haven't changed it and you're not changing the scope of its use, you're not feeding it in some different input parameters, then you're going to have a much easier time revalidating it. You can know that if you've tested it thoroughly the first time, if you haven't changed it, you're not going to need to test it to that same degree again, provided certain criteria met. You're not passing in flaky values and things like that. Hopefully your code's going to allow for that anyway. So ultimately it will improve the quality as well, because you're not creating new code that needs to be revalidated that might have some latent defect in there that you didn't quite catch the first time. So code quality will improve, and it allows you to maintain control. I always think back to when I first joined Astrium in 2008. They'd got a problem with a particular, it was an Agilent benchtop power meter, and they were having a problem with it when they were doing the reset functionality. It wasn't behaving as they expected, so somebody said, "Well, Chris, can you take a look at it?" So I said, "Yeah, sure." Where is it? Oh, it's in Subversion. You can just go and find it. So I went into their reuse library and had a look, and found 9 copies of an Agilent power meter driver, 9 different copies, all that did different things, some of which exhibited the bug, some of which somebody fixed and then left the company, others which didn't exhibit the bug for unknown reasons. So that's a situation where they were totally out of control. Whoever had written the first instance of the driver hadn't made it accessible to other members of the team, so when they came along and they needed to create something similar, their instinct was to start again, or worse still, take a copy and branch it off and create their own version of it. So code reuse will help you maintain control as well. So why don't we do it? Well, I think we've probably all been in that situation at some point. You know, somebody sent me some LabVIEW code and I went to open it and it's like, can't find this sub-VI, can't find this. Because we haven't necessarily used the tools correctly, or we're even not aware of what tools can help us do this. So rather than tell the person who sent me the code something's missing, it's like, phew, can I be bothered? I'll just write my own. And that temptation's there, and I think we've probably all had that situation. Or worse still, I've got this reuse library and I wrote it in LabVIEW 2013 and I went to find my VI and somebody's upsaved it in 2015. I'm like, oh geez, now I've got to back save it to 2013. Do you know what? I'll just write my own version. I remember what I did the last time. So saving over in newer versions of LabVIEW also can hamper reuse, especially if you're just using a network repository or a source code repo and somebody's saving it in a newer version of LabVIEW. So we're going to talk a little bit today about some of the tools to help us get around these situations. The last bit of syntax that I'm going to talk about, I'm going to be talking about something called released code. Now when I talk about released code, I'm not talking about code that we send to a customer or code that we sell or put on the tools network. I'm talking about code that is needed by another part of the project. So we've maybe got multiple developers working in parallel and each developer is working on a different part of the project. When I'm talking about release code, I'm talking about something that I'm going to release internally within a team to be used by other people. Okay, so my project that I'm working on, I might be working on, for example, the data acquisition part or the analysis part, and it might not be reused in multiple projects, but it needs to be controlled. So say, for example, I'm writing the data logging part of a project, I need to release that to the other members of the team so that they can build the data logging functionality, its API, into the other parts of the function, in the other parts of the application. So I'm talking about code that we're releasing internally. So, tools that we can use. I'm going to be talking a lot about VI Package Manager from JKI. It is the kind of the preferred tool for downloading code from the LabVIEW Tools Network and the OpenG packages. But it can also help greatly with controlling your reuse and managing your reuse. But there are other tools. I'm going to be talking about VIPM, but there are other tools. LabVIEW source distributions. So actually, just quick straw poll. Who's using VIPM for anything other than downloading free code from the tools network? Okay, so a couple of you. Anyone not using VIPM at all? Okay, so I think most people are using it to get the free stuff, and a few people are using it to do a few other things. LabVIEW source distributions, yeah, VIPM under the hood uses some of the LabVIEW project API for build specification API for building source distributions. So the two are kind of closely related. The LabVIEW source distributions, again, build specifications can be used for distributing code. Source code control, a little bit similar to what Camille was demonstrating yesterday, but using source code control in order to share code amongst developers, feature branches, for example, and PPLs. I'm not going to dwell too much on PPLs. They offer some benefits, they've got some pitfalls. If you want to find out more about PPLs, go and talk to Yarabit in the middle. He's the master of PPLs. So, my first tip of my 5 tips then is modularize the code. So, within an application, define what the various modules need to be and then modularize them. I've got these 2 blocks here because depending on who you talk to and who you are in your organization and how you work, these 2 might happen in a different order. Certainly, internally at Delacor, we try and do test-driven development where before we've actually written the code, we've written the unit tests, so we've figured out how we're actually going to test the code that we will write. But as long as you're actually writing a unit test, perhaps you'll create the code first and then write the unit test. But you're doing those two operations. And you're validating the code. You're validating, verifying that it works, it behaves, it tests its input parameters correctly, and all its behaviors are expected. And then we build a package from that code using VIPM, as I'll show in a minute, and we release it. We inform other members of the team that this package is available to be used. So we notify the team of a new version. VIPM's got a few features we can talk about a little bit later for how you can let other team members know what is available. So each module, each block, so it might be the data acquisition block, the data logging block, the user interface block, the error handling block, but each block has its own repository and its own release cycle. So my application has become a series of smaller applications, each with its own release cycle. So what's good about that? Well, it means that developers can work on modules in parallel. Okay, if you're a CLA or aspiring to be a CLA, then one of the things that you're going to be having to learn and understand is how an application can be divided up into several subtasks and several modules that can be worked on independently. So developer.
Can I say, even if you're not a team, then you do it by yourself?
Absolutely.
It's good to be able to focus on one part
Yes.
at a time, not have to understand all the details of everything else at the same time.
Yeah, that's a good point. But if you want to pass the exam, you've absolutely got to know about things like that. So, APIs get defined early on. So the first thing, if I'm writing my data acquisition or my data logging module, is I'm going to define what the API of that module is. What are people going to want to do with my module? They want to maybe start acquisition or configure the acquisition first, the channel number, the sample rate. They're going to then want to start the acquisition. So there's some kind of method that they're going to call on my module to start the acquisition. They maybe want to test obtain a spot value and then stop the acquisition, and then they'll send that data to the data logging module, for example. So the API for that module gets defined very early on, and having to build a released version within a team encourages the testing of those parts, because I know that Greg's going to be calling my start acquisition method, so I'm damn well going to make sure that that's working. It also enables you to spot circular dependencies as well. So if you broke your application down in that way, if I'm calling somebody else's data logging and they're calling my DAC, then I've got this potential for a circular dependency between the modules. By breaking your application down into these different modules, that enables you to spot those dependencies. But doing this thing, it gives you all these great benefits, and we've got this modular application, all these different parts that can be tested. So I can define my API for my module. And the nice thing is, actually, I didn't say there, maybe I'm going to get onto it in a little bit, I can't remember, but the API gets defined early on, and actually, I can release my code without all of the functionality implemented, but I can release it with some placeholders in there. So Greg, I can write a VI that's called Start Acquisition, and it's got some inputs, and actually the VI is empty. But I can give him a placeholder to put in his code, and as long as I don't change that interface, I'm then responsible for completing that code. I'm not affecting what Greg's doing. He can work in parallel knowing where he's calling my VI. So the API can be defined early on, and it allows the team to work together in parallel. But it causes a couple of predicaments. So these are things, when I say predicaments, I'm thinking of things that we've now caused by breaking our application up in this fashion. So it requires separating the source code from the release code. I'm working on my source code, I'm building my data acquisition library, and I'm now releasing it to other people. I'm going to continue to work on my data acquisition library, but there's another copy of it floating around that's the current released version that maybe doesn't have all of the functionality built in. So that's something that I need to cater for. And we're going to go through how we solve each of these problems. I need to manage versions. So version 1 is just an empty API of 15 VIs with no LabVIEW code within them. They're just empty VIs. And then the next version, some of the functionality is implemented. So we need to think about how do I manage those different versions and what are the differences between them. Managing the release process. How do I get that code out there to other people? How does Steve know that he's now got a new version of my data acquisition library that he can take advantage of, and bits of it actually work? We've got to manage that process. So, the first, I'm I'm not going to do live demos. I've got some videos that have been pre-recorded, but I'm going to talk you through these videos as we're watching. So the first demo is really going to show how we can take some source code that we've got that works and build a LabVIEW package, a VI package from that source code and generate palettes and things that other developers can then use. So let me set that running because I think this is quite a slow start. So there's a lot to talk about in this video, and please bear with me. This is the rest of the videos are like 1 minute in length. This one's a little bit longer. So, and it's slow to start. So what we're going to be doing here is blatant blog. I apologise. I'm using one of the shipping templates, one of the shipping examples from the toolkit that we recently released as an example because it's got lots of code in there already, and it's got a couple of different modules. It's got a thermal chamber module and a device under test module. So it's kind of a typical example of an application that's got different parts, different modules to it. So I've just gone into the help find examples in LabVIEW and pulled up one of the shipping examples. I'm just demonstrating actually what this code does. So the module that I've pulled up here is the thermal chamber module, and I've got an API tester that allows me to test the API of my thermal chamber. So that down in the bottom right was my thermal chamber module, and its API has functions such as set target temperature, set ramp rate, turn the heater on, and these are the functions that other developers might need to use when I release that code to them. The other module that I'm going to pull up is a device under test module. So this might be a module that somebody else has written to interface to our unit that we're actually going to be testing. In this particular case, the device under test module just performs a self-test. It powers on the device and it performs a self-test. So what I'm actually doing now is I've now got so that was my source code, my project in its various components on disk, and I'm now going to make copies of them. I'm purely doing this so that I can prepare them for building a package. So I've got a repo, a mercurial repo locally. I'm creating a temperature chamber controller directory, and I'm going to paste in the code from my shipping example into that repo. And I think I do exactly the same thing with the device under test as well. So I've got, the idea is that I've got two modules, a thermal chamber controller and a device under test module, and I'm going to build them into reuse packages. So I'm just saving them onto the C drive at the minute into this repo. I'm going to commit them. Everybody's using source code control, right? So I'm just going to go through and commit them and paste. This is the bit where we haven't discovered pause on the video, so I would have normally paused it. But the rest of the videos are much quicker. So yeah, I've got my repo. I'm closing my example, and I'm going to go and commit those. Okay. So one thing to point out here is that 99% of the features I'm going to show you are available in VIPM free of charge. You don't need to buy the professional version. There are a couple of caveats to that we'll talk about right at the end. But actually, all of this stuff that you're going to see, you can do for free. All of the toolkits, things like that I'm showing you. This particular tool I'm using for Mercurial, HG Workbench, they're all free tools as well. So I've got my two reuse libraries, the source code behind my two reuse libraries now on my C drive. They're both committed. I've pushed them to the repository. They're under control. I'm now going to just make sure that they still work, and I'm now going to add them to a new project just to show that they still work. So I've got a new LabVIEW project. I'm going to add my two libraries across to them, just run them up to make sure that they still work. They have all the dependencies with them that they require, and then I'm going to build. Okay, go. Resolution on this is awful as well. Okay, so I'm going to add my library, and I'm going to add the API tester as well. The first thing I want to make sure is that when I distribute a reuse library to somebody else, I want them to be able to open up an API tester and immediately see how does that library work, how do I interact with it, what are the methods that are going to be available to me, and actually see them working. So I'm not just sending them a library of reuse code that they can use, I'm actually giving them a tester as well that they can interact with, click on buttons and see an immediate response. So I've added that to my project, including the API tester. I'm going to go ahead and open that now. So I've got my my unit under test library. This is its API tester, and its API has a method, a power on method, a perform self-test method, and that's it. It's a very, very simple module. But I've shipped the API tester so that people can interact with it and see. So now I'm going to fire up VI Package Manager and build a reuse library. So I'm using VIPM over here on the right, and the first thing I do is I tell it where the source directory is for my reuse library. So I point it at the root directory for my source, tell it where it is. So it was that repo that I created on the C drive, and give it a name. So I'm going to call this one Thermal Chamber Controller, something along those lines, and hit the OK button. And this is where we discovered pause, so things start to happen a lot faster now. So once we've done that, VIPM then comes up and asks us to define or to build a specification for this package. So we can do things like we can define what its palette will look like. So when I send that package to Adrian, he'll get to see that palette in his LabVIEW development environment, and we can define which VIs appear in that palette. So we're customizing which VIs the end user gets to interact with from within LabVIEW. So we can define custom palettes. We can exclude certain files that we don't want to include in the package. Maybe we want to include some documentation or don't want to include some documentation. We can define dependencies within packages. So if I've got a data acquisition library, but it requires that you've got one of the libraries for one of the NI DAC devices to be installed, one of the ID net drivers, for example, then we can list that as a dependency. And then we hit the build button, and automatically a few seconds later we end up with this single package, this single file on disk that I can now distribute to other members of the team. If they want to install my package, they double click on it and it installs, and they say OK, tells them a little bit about the details that I filled in earlier. If we then go to LabVIEW, there's my palette. So those are the VIs that I just built from my thermal chamber controller, and I can start to string them together and build a program that uses the thermal chamber module that I just wrote and packaged. So VIPM 101, in this case I'm using the device under test, so I'm just returning a self-test result. I've strung some of the VIs together that I've provided on the palette, and somebody can write a program that performs a test of the device. So they're calling the exact same VIs. So that's that's kind of the 101 of reuse is I've got a library, I want to share it and make it available to other people, and it has a version number in there that auto increments every time I hit the build button for the palette for the package. It auto increments. So that's kind of like the beginnings of code reuse, if you will. So that's how getting started. Point. What else am I going to do? I'm just going to save that. Yeah, we can skip that. Okay, so that's great. We've made our code available via palettes. Okay, so we can now start sharing that with everybody else, and that's cool because then QuickDrop finds it. So once I've installed my thermal chamber package, people can use it easily. They're not having to go and browse some network directory. It's there in their LabVIEW palette. If they use QuickDrop, they can start typing and they can find it. But hang on a second, we've got a problem now, haven't we? Because I've got code that I've installed into vi.lib, and I've got source as well. And we know that LabVIEW has problems when you try and open two VIs at any one time that have the same name. It doesn't like that, right? Well, I could put it might be a library, so maybe I can get around some of those problems. But we still have this issue where I perhaps have to uninstall the code when I want to work with the source and then rebuild my package and reinstall it. So one thing that we can do is that's actual plan. So let me show you an example of that. So I've got my thermal chamber controller package installed. It's got this nice palette that we saw a minute ago. I'm going to drop the API tester down on the block diagram and run it, and I can interact with it as I could previously. And then I can go and browse my C drive and find the exact same thing in source code. So I've got the source and the deployed package open at the same time. So I can go and do that. And it gets a bit, come on, open, there we go, open file, open the API tester. So now I've got the source code for my API tester and my deployed package open at the same time. And if I do context help over them, they've got the same name. So hang on a second, which one am I using? This is confusing. I could end up with horrible cross-linkages. And the only way to actually tell is to double-click on the icon, look at VI properties, and look at its path on disk. So that's hidden. That's not something that's really very obvious at all. So I can't tell which is the deployed version that I've given to Greg and Steve and which is the source code version that I'm actually working on right now. So the thing that we need to do is rename our code as we build it and release it. Okay, so that allows us to differentiate between source code control, the unreleased code, and the release code that other people are going to be doing, and we can rename it as part of the build process. So it gives us a really quick visual confirmation that we're using the released code rather than the source code, so it reduces the risk of cross-linkages because it's a different named file. And we can add them, prefixes, suffixes, to every single VI, or just the library, or just the class. We can add them in VIPM3, and we can do it as part of the build process. So we don't have to do anything else. We don't have to relink VIs. We don't have to relink the libraries or any of the sub-VIs. We can tell VIPM, as you're building this package, rename its contents. Give it a prefix, give it a suffix. You can also do it in source distribution in the build specification as a build action, a post-build action, a pre-build action. So you could do it if you're using source distributions. So what does that look like? So how easy is that to do? Very. So VIPM, open. And on the item settings page, we can see the files that make up our package, and we've got this option to enable renaming down in the bottom left. It's deselected by default, but we can tick it and say enable renaming. We can choose whether it's a suffix or a prefix. We can type in some text there, hit the rebuild button, save the changes, hit the rebuild button, rebuild our package. Install our new package. Install. And now when we open it in LabVIEW, we'll see the renamed, we'll see that even just by hovering over it with context help. So now if I hover over open the library, hover over it in context help, I can see it's been renamed, it's got the new prefix. So I now know, I'm now aware of which one I'm actually looking at. Okay, so I know whether I'm working with source or whether I'm working with deployed code. And I don't need to go to the VI properties anymore to actually see which one I'm working with. So, rename and release code. Problems with that? Don't go crazy with prefix names. I mean, especially if it's a class where it's then going to appear on some property node on your block diagram. If you start renaming these things, they get huge and they take up a lot of block diagram space. So just give it enough of a prefix or a suffix to highlight to you that it's released code. But don't go crazy.
There is a way with classes to specify a short name.
Within the properties of the class itself, yeah, you can shorten the name. Or also rename just the class itself. Don't rename everything within the class, just rename the class itself. It might go against the style guidelines. It depends how you work before you started doing this. If you follow like the NI style guidelines, they perhaps tell you to rename to name a VI based on its function within a project or where it sits within a project hierarchy. So if you then start prefixing your deployed code, your names are going to get really huge really quickly. So you need to look at that and temper it a little bit, but just some indication that it is released code, not source code. And also if you've got dynamic loading VIs that are required of looking for a file on disk by a particular name, you need to take that into account if you're going to be renaming things programmatically during the build process, that dynamic loading might not work. any longer. Oh, and loss of class mutation history as well. So if you're using classes and you're relying on that, you're renaming the class at build time, so you can lose the mutation history of a class. So, tip number 3. If you're doing this and you're rebuilding these reuse packages, how do I check what version I'm using? Well, surely the only way to check what version I'm using is via VIPM. So I've now got to load VIPM, get this huge long list of packages, find the one that I'm looking at and see what version it is. Well, you could add a version number to the description of every VI in your package. You could do that programmatically, you could write some scripting code. Well, yeah, but then that makes every single VI in source code control look as if it's changed, because and every time I rebuild my package, I've got to renumber or give each VI in my package a new version number. So one thing you can do is you can add a version to the VI description of the VI programmatically during the build process. So you could actually write a scripting tool that will add it, but VIPM Pro has the option to add author, VI version and any other information without modifying source. So you're not changing your source files on disk, you're adding that information at build time to the package. So this one, I do just that. So I think this one I add the name of this presentation to the VIs. So in the it's in the edit VI description box down at the bottom. I can add some text to that. So I'm going to add the title of this presentation. I can add that text in there, save my package, rebuild, and come on, type faster. Yeah, save my package, rebuild it, and I've just you can have version number, VI description, author. Okay, install my new version of my package. Now if I look at the palette, show palette, hover over it using context help, I can see that I've now got version history. There we go, context help. So the text that I just typed in has now made it into the VI properties, into the description field, without me changing the source file on disk. So I can set that to automatically have the build number every time I build, so I'm not having to change the source code, but it's there. So the final predicament, if we're building these packages, is when we've got all these packages now floating around. We've got my data acquisition package, Steve's data logging package, Adrian's error handling package. We've got all these packages, but how do people know what they need to install? Say, for example, a new team member joins the organisation, somebody comes on board and joins the project. How do we know what packages they need before they start work? Well, VIPM has something called package configurations. Now, using a package configuration is something that's in the free version. Building and defining a package configuration, you have to use the paid for version to do this, but you could have just one person in your organisation building the package configurations for everybody else to use. So you wouldn't need to give that to everybody. So that allows you to keep track of the release code. So effectively you're keeping a list of release code and what versions are needed on a particular project. A package configuration is a list of all the packages that are needed, and it can contain the packages themselves. So think of it as a package of packages. It's one file that I can distribute to new team members, and that gives them all of the release code that they need. So that would give them the error handling, or the data logging, or the data acquisition libraries. So it's a way of distributing that. VIPM free can apply them, and you can also import IDNet drivers. I'm not going to do the demo. If somebody wants to see that, I can show you separately, but it's quite a long demo. But you can import IDNet drivers straight from ni.com into your package. So if you're writing a data acquisition module that uses a particular IDNet driver or something, then you can build that into a single package and distribute it. I'm going to skip that one. So how do you manage all of these release modules? And I've just talked about 3 or 4 different modules that I've released. They've got nice version numbers, they've got revision histories. I can identify that they're source code or released code, but there's still, I've got this collection of package files somewhere, so I need to be able to manage them. Yeah. So a couple of different ways you can do it. You could have an FTP drive that people collect them from, or a mapped drive, just a network share that people know to go to and check. Dropbox, for example. We use a source code control repository, so we have a packages repo where we keep all of the packages from the different projects that we pull from centrally. So I know that I need to go and pull the latest version of that repo and install the latest version of any packages that have been updated. There's also a thing called VIPM repos. It requires everybody to have the pro version, unfortunately, but that effectively, you have a central network share, and when people publish new or build new packages, they get published to that repository, and then anybody who's in the team who subscribes to that repository, every time they start LabVIEW, they get a message saying this package is updated, and they can choose to install it if they wish. There's also an RSS feed. So if they have their email client set up to subscribe to the RSS feed, then they'll get an email in their inbox saying data acquisition library's just been updated to 1.2 or whatever packages they've subscribed to. So, but unfortunately that requires everybody to have the pro version. So, anybody got any questions about packages, Greg?
Quick drop.
Quick
You
drop.
say if you install a package,
Yes.
you can access it through quick drop.
Yes.
Is there a setting in VRPM where you set that? Because I've got a package which I've built myself.
Yep.
Installed it. I can see it in the palette, but if I use quick drop with the names, it doesn't show up.
Where are you installing it to?
Now this is the first package I've ever built, so I was probably doing it wrong.
Okay.
But the package is being installed into vi.lib.
Okay.
Is that wrong?
No, that should work.
You should see it.
You should see it.
Did you just install it? You have to restart that usually.
No, I installed it like last week or the week before. It's not something we can. I mean,
Yeah, we can.
look
Yeah,
at
but
it later,
you should be able to
you
see.
should be- yeah.
There are issues if you build packages that are built outside of vi.lib. There's an issue in the palette builder, and you don't get palettes. Even if you define and design a really nice
Yeah.
palette, if you tell it this package is going to be installed into C users, Greg Payne
Yeah.
documents, it'll build the package and it'll be available to you in LabVIEW, but the palette won't be built.
Yeah. Okay.
It'll just be empty. So if you build into vi.lib, they work. We'll have a look at that one. Great.
Yeah, so
Um,
when you advance with the package and maybe it stops being compatible backwards, like you make modifications and it's not, compatible with previous versions anymore.
Yeah.
How do you solve that problem? Like with all versions of all projects that are using the old version and all that.
Define your API better in the first instance.
Yeah, well, yeah.
You can also rename it, the new package, give it a name, so it's not an upgrade.
Yeah.
And put it in exclusion, that this excludes the previous one,
Yeah.
and so they can choose to upgrade it.
Yeah.
But for that you need the pro version, do you?
No.
No, a free version can do
Alright.
that. But yeah, if you
define-
change,
you can define this is incompatible with this.
if you're making something available to the other users though via the palette, you're wanting to promote its reuse. So you
Yeah.
really you need to be asking, why am I changing the campaign on something?
No, I know, but sometimes it happens.
Yep.
So,
Yeah.
This is a really mundane question, but what useful descriptor would you put on as a suffix? I couldn't see in the video what you were doing.
So I actually, I've done things, so I worked on a project recently that was a test and deployment project, so I put TSDPLY or something like that, and I put it as a prefix, just so that I would know really quickly in the title bar, this is deployed code, this is code that I'm expecting other people to use, so I just put it as a prefix.
In release code, somebody might not necessarily understand why you've got DPLY underscore at the start of your file name or anything.
And then you put it back.
Prefix, yeah.
You could suffix it or something
I
like
like
that.
you put a little r and the version number.
Yeah.
Personally.
Yeah, I mean the package has its version number already in the version number of the package. So you've got the package name, its version number .vip, but once then the code's installed into LabVIEW, once they've installed that package, then they're just seeing the VI names as you saw them in source.
Yeah, we do a release version for everything, so when the project is released,
Yeah.
so that's the version number I would like to see.
Yeah.
Is I look at it, that's version, you know.
By doing it as several modules, though, you've got the option that if we're then deploying it onto a clean machine, I can create a package configuration, this package of packages, which has got all of the underlying drivers. But then it gives me the ability to then say, the customer needs a change to the sampling rate. I can push out a new DAC driver. I can give them a new package of the DAC driver that's still controlled. It's still rev controlled. They won't want to go back to the initial install. They've still got the original package, and then they can apply subsequent component packages as upgrades for individual things as well. You've got that option, should you wish. But yeah, I mean, it's a good point. Would they understand? Your end user probably, if you're deploying it to somebody that needs to ask the question, why has it got a suffix or a prefix, they've probably not got access to the source code. So
Those videos, there's a Delacor on YouTube.
there is, yeah. Sorry about the resolution on some of these projectors is pretty poor. There's a if you go to delacor.com media, there's a link to our. We've got all of these videos on a YouTube channel. So there's a ton of stuff also about using VI Package Manager and using source code control. So getting source code control set up, there's quite a few hours of videos up there. So you've got to look at delacor.com media.
Media-2.
Sorry?
Media-2.
Media-2.
Yeah, I wonder what Media Dash 1 is.
That's the hidden secret stuff. You have to pay for that.
Secret stuff.
There's a box where you put your credit card number. Any other questions on VIPM?
Yes, I would like to ask you about the new point of view. According to you, what is the advantage of VIPM over the source code distribution?
Over the source code distribution, is a good question.
The basic one.
Palette building.
Okay.
Palette building, and that doesn't just extend to. That doesn't just extend to LabVIEW as well. But I use VIPM to distribute test stand code as well. So you can distribute test stand code and insertion palettes. So you can do exactly the same thing that we're seeing here with LabVIEW, but to share test stand sequences and reuse test stand sequences within a team as well. It's treated a little bit like a second-class citizen. So things like when you tell it which directory do I want to install into, you have to set up your own directory for test stand because it doesn't know what test stand is. But it can do that, so it allows you to build palettes, so that's one advantage. Having the package configurations is a big advantage actually, being able to say, here's one package and this is everything you need to work on this project right now. These are all of the release packages.
Okay.
Anything else? Okay, thank you very much. Thank you.